Okay, so again, we're doing derivatives. And so here's the function 1 over x squared, f of x equals 1 over x squared, and want to find the derivative. So I'm using this definition of the derivative. I'll call the derivative f prime of x is equal to the limit as, oops, I shouldn't put that, delta x goes to 0 of f of x plus delta x minus f of x, all that over delta x. So this is essentially the slope formula, right? So here I have f of x. And now if I move forward some amount, delta x, then this is going to be f of x plus delta x. And then I can use this is just a slope formula between those 2 points. And then I take the limit as the step size goes to 0, and I get my derivative. Now this is a more challenging question, and I'm probably going to make a mistake, but I'm going to do it anyway. Okay, so let's just plug in our stuff and start from the beginning. So here I have f prime of x is the limit as delta x goes to 0 of, and let's say f of x equals 1 over x squared. Okay, so I'm going to put in my stuff. So I have 1 over x plus delta x squared minus 1 over x squared, all of that over delta x. Now, you can see the first thing we'd want to do is just, this is put in delta x equals 0. But then I have here something divided by 0, and that's bad. Okay, so let's go up here and get a common denominator between these two so that we can combine these two fractions. So I have the limit delta x goes to 0. So this one I'm going to multiply the top and the bottom by x squared over x squared. And this one I'm going to multiply by x plus delta x squared over x plus delta x squared. So I get x squared over x squared times x plus delta x squared minus x plus delta x squared over x squared times x plus delta x squared, and then all of that over delta x. So before doing that, let's combine these. Let's combine this. So I get the limit delta x equals 0, and I didn't work this out beforehand. So like I said, there's very good chance. So I can combine these as just this in the bottom with this on the top, and I get, I'm going to write it out, x squared minus, so we're going to square this out. So let's factor this, or FOIL this. So it's going to be minus x squared plus 2x delta x plus delta x squared, all of that over x squared times x plus delta x squared, all of that over delta x. I know it looks bad. And so now let's do this again. So if I distribute the negative sign, I get x squared minus x squared minus 2x delta x minus delta x squared, all of that over x squared times x plus delta x squared, all of that over delta x. So this is this is a big fraction, and this is delta x over 1. So I can divide this stuff by that by taking the inverse. So let's do that. I get the limit as delta x goes to 0. So if all that stuff, oh, actually, look, that cancels. Does anything else cancel? No. Okay, so I get negative 2x delta x minus delta x squared over x squared times x plus delta x quantity squared, and then I have 1 over delta x. So now I have a simpler thing to do. Now on the top here, these two terms both have a delta x in there, so I can factor out the delta x. So I get delta x times negative 2x minus delta x over x squared times x plus delta x quantity squared delta x. I like to cancel in red. Let's cancel. So here I have a delta x and a delta x. They cancel. So that, oh, I left off my limit too. Limit delta x goes to 0. Sorry. Okay, so now I have the limit as delta x goes to 0. I have this negative 2x minus delta x over x squared times x plus delta x squared. Okay, I can actually, what if I put in delta x equals 0, and I don't get 0 over 0 or something over 0, then I'm cool. Okay, so that's fine. I did it. So now I get negative 2x over x squared times x plus 0 squared. So that's negative 2x. This is going to be x squared times x squared, which is x to the 4th, which is equal to negative 2 over x cubed equals f prime of x. There you go. Did you guys have fun with that? I sort of had fun with that. Okay. So I'm going to, I said I was going to do a numerical derivative, and I'm going to do that for this too. I'll probably do the previous video and this video numerical derivatives using Python in one video. Okay. Talk to you guys later.